Okay, so like I said, we'll go over these problems we had for homework first thing this morning. Then we'll look at shear diagrams and moment diagrams, see how to construct those. I think you'll find that those are not too awful hard to do. So again, I think this chapter is going to lend itself to making your grade better. I also did some looking just now before we came to class, and I'm probably going to do something I've never ever done in my life, ever. I'm going to drop your lowest grade. I checked, it's not going to make that much difference, but it might push some of you to that next level, which I would do anyway. So I'm going to do that, and we'll probably only have one more test. All right. The irony of that is, when I was looking over those, when you look at your grades, the people that probably, I'm guessing, work the hardest because they've got higher grades will be dropping more points than the people that didn't work so hard. Does that make sense? Unless you just flat out bombed one test, you know. But typically, I mean, some people are dropping a 90s grade, and other people are only dropping a 20s grade. And the people, so they're actually giving up more, but it doesn't make any difference because they already have a high grade anyway. So, pretty much, yeah. So, it'll push some of you, like I said, it'll push you from a high B to a low A, which typically I do anyway, once the semester's over. So this way you'll know ahead of time what you're looking at. Okay? So, and we'll just go from there. So and anticipation then is that we'll finish this stuff up today. We'll have the moment and shear diagrams homework done for Monday, and then there's a good possibility that we'll just have a test on Wednesday. And I'm not going to start something new for Friday and then possibly Monday. That's not going to happen. So, do what? Call it done, yeah. Yeah, the last day could be Wednesday. So, sorry if that upset you, but that'll give you more time to worry about your other classes as well. So, all right. And the last test will be just a test over Chapter 13. I don't have too many finals. To do the stuff in 13, you have to have known what you should have known in Chapters 1 and 2. So, and we just added to it. So that's the way it's going to be. Okay. I think in the syllabus it even says that it's basically comprehensive because you have to keep remembering that stuff to move on. Didn't hear what? Well, I didn't set a date, but the test will probably be on Wednesday. Yeah, this a week from.
I think it's the 17th.
That's.
I'll check it out.
Yeah, that's probably about right. Okay, so, and it'll just be Chapter 13. All right.
Yeah, it's the 17th.
Do what now, Hari?
Chapter 13, for the preparation of Chapter 13, we need to revisit the Chapter 2 and 4 years.
We're not going to do Chapter 14.
No,
He said revisit Chapters 2 and 4.
yeah, I mean, some beam,
Review.
yeah, beam related, this Chapter 13, the basic thing of beam we studied in Chapter 4 or 2, 3, 4 years.
What about them?
He said that's where the basic ideas of 13 came from at the beginning.
Yeah, well, that's possible. I don't remember. I didn't look right offhand, but yeah, basically all you have to do is find the reaction at the supports, right?
That is in Chapter 4.
Yeah.
I don't remember.
Yeah.
I just remember how to do it.
I think it's 3 and 4.
Yeah, that could be. But
You said 1 and 2, that is not.
oh well.
That is free.
Sorry. Okay.
I read.
And not 1 and 2, 3 and 4.
You get
Sorry.
bad information there, man.
Picky, picky, picky.
He's made it down.
Don't put that on my evaluation, okay? He screwed up. He said 1 and 2, and it should have been 3 and 4. It's all on video, so I remember I didn't take anything out of those videos, so it's out there for the world to see, but I really don't care, you know? So I think maybe hopefully you've still learned something over the course of this semester, so that's the only thing I care about. I don't care about whether or not I'm real fancy or not. It just doesn't matter.
Can I be more clarify? You mean you will drop one quiz?
Yes, your lowest quiz. I'm going to drop your lowest quiz, and then I'll still divide by the full number. No, no. I'll drop your lowest quiz grade, and then divide it. Right now, I divided it by 6. So after this next quiz, I'll take your lowest quiz grade out and divide it by 7. Okay. So and then I will post in Blackboard. I've been posting your grades. So I will post your grade. There will be a total column, and then there will be I think they call it a weighted column that shows your percentage. And then I will also have a column that will show your lettered grade. So that will probably be up before you see anything on your report, you know, from the school. Okay? So that's how that will work. So you'll have a little heads up what to expect, so if you have to hide your grade card from anybody. So I don't, from what I remember I just did a real quick check of everything up till now, and everybody's grades were fine. Everybody that was not going to do so well has already dropped. So the rest of you should be fine, okay? As long as you're all okay with a C. Well, C's average, right?
Yeah, but I'm not at it.
You're not, well, you're leaving yourself open on that one. You're right. You're not normal. It's my turn to pay back.
That really help for me. My one quiz is really down.
Well, you won't have to worry about that now.
Huh?
And he's doing that just for you. First time ever.
First time ever. It's a new world record for me.
No, I have more than 5 quiz, almost more than 4 quiz. I have over 90. I have one quiz. less than
Yeah.
45.
Well, there's several in here that did that. Almost everybody, actually, had at least one really bad one, and I don't think they were ever the same one. Just for whatever.
Chapter 13.
And I think some of that could be attributed to life happens, doesn't it? It really does. So I understand that. And ultimately, it's not really going to change your grades that much. That's what I was looking at. But it tends to make them better. So. No, I didn't say that. Don't take it as I'm being really, really easy. I haven't even looked at that in the other class, so I was looking through the grades and thinking, let's see what it's going to do, and it really, for this group, I tend to believe this group probably worked pretty hard. So that's like I said, I've never done it. Never ever in 28 years. Never done it. And maybe I am getting soft in my old age. I don't know. I don't think that's the case, but I did want to get that out there before you did your evaluations.
Too late.
Oh, okay, I'll take it back. No, not at all. Well, like I said, hopefully it'll all work out, and everything you've learned up to this point will get you through what you need to do when it comes project time. So, okay, so 3.7. By the way, there was at least one problem in the solutions that was not right. Okay, and I went back and checked with other people to make sure what I was thinking was right, and it's like, yeah, that basically what it amounts to is they didn't do their proofreading for whatever reason. So we'll get to that. So 13.7, what do we have to do here? Find our cursor first. Come on. So the first thing we have to do is, what I do is forces into y. So I can find a reaction. And I've got AY. I'm calling this AY right here, right? And we'll call this one BY. Since I don't have any forces acting left or right, I don't have to worry about the x's at all. So AY plus BY minus 12. And again, if I get going too fast through here, just say something, and you can ask questions by all means. But I think this part of it should be relatively easy to get along with. Summation of the moments, and I like to do mine at A. So I've got negative 12 kilonewtons at 5 meters plus BY at 11 meters. So I can solve for BY. 12 becomes positive because it's going to the other side, right? So 12 times 5 is 60, right? Divided by 11 is 5.45 kilonewtons. And me being me, I still like to put the up symbol on there. We know it's going up, but just the way I am. Then we can solve for AY, because we can put BY up here, 5.45. And we leave AY where it's at. Everything else goes to the other side of the equation. We got 12 minus 5.45, and we should end up with 6.55 kilonewtons. And it's up as well. And I'm going to have some more room here, aren't I? That's what's nice about this. I don't have to worry about erasing. Just moving it down. Whoa, a little too much. Okay. I like these ones. They made them as a group. Works out pretty nice. Okay, so now we got a little more paper. All right, so we okay on that? Like I said, that should have been, that was first part of the semester. Chapter 3 and 4. Chapter 4. Okay. So then we need to find out what the shear is in the moment. So we had first we're going to draw, and they ask us to do that at 4 meters, right? So they want us to cut it somewhere right through here, 4 meters. So we draw a free body diagram of that. It's going to look something like this. We got this force here, which was 6.55 kilonewtons. And I believe that's it, isn't it? Okay. So our shear, signified by the V, is simply we just add those all up, and we only have one, so 6.55 kilonewtons. You'll want one of those on the quiz, won't you? The moment, and oh, by the way, that came out positive, so the shear would be going like this, right? This piece is pushing up. Okay, so the shear, the internal shear of that beam has to be pushing back down.
So we need to draw that on a free body diagram?
I think it would probably be best.
Okay.
Yeah. I think that could be expected. This chapter is so easy anyway.
We read it next to the kilonewtons like we write the rest of our errors. Is that okay?
Yeah, I guess that'd be okay. So he's just saying, do we want to put it this way? Right?
Yeah.
Yeah, that I would say that would be acceptable. Okay.
So we should have an area of not a positive or negative like they do in the solutions in the book.
Yeah, or if you put, that would be what would be tricky, because if you had a negative number here and you put that arrow going up, then that would be kind of contradicting itself, you know. So I guess if we're going to put the arrow, you probably ought to make this an absolute number. Fair enough. Let's see, then the moment part of that, we have to show everything that's going on here. Let's see. So we've got, for the moment, we've got 6.55 kilonewtons, right? And that is 4 meters. Oops, let me go back and get that eraser real quick. Meters away from where we're looking at the piece, right? And that's 26.2 kilonewton meters, and that is going that way, counterclockwise.
I have a question about direction.
On the what?
Direction, the direction of the young.
Oh,
The moment,
of the
moment at B here, that moment at which point?
yeah, we could say that, couldn't we? Moment at, well, it's really not at the shear, if you will.
And that direction of 6.55, it looks like clockwise here.
Yeah, remember, for this section, we're looking at the internal moment, right? Okay, then the way the convention of the book shows us is that if it, here now, and I don't like this, but this is the way it works, here now, up is positive and down is negative for the moment equation. Okay?
So we're gonna have-
Here we had to do it like we did it the old way. When we're talking about moment, for the bending moment, the resisting bending moment, we're looking at what's going on the opposite. It's a different way of thinking about it, because we're looking at the internal shear, or the internal moment, as opposed to what's going on at the reactions, which is actually an external. Okay? So we flip that direction. Just like we're saying that the shear, it's a positive value, but it's going down. It's not very intuitive to what we've been doing up to this point, but you have to wrap your mind around that and say, you know, because it's going up, and it's making this thing go clockwise, which in our mind is typically a positive or a negative value. But again, we're looking at what's going on in the resistance right here, internal. So you have to flip it and think just the opposite. And that's what we talked about Wednesday.
So our V is a negative.
The V, yeah, the shear is negative.
6.55 is positive.
And again, the 6.55 was positive. This is a positive value. But again, think in terms of what's going on at this beam. If this beam is trying to push up, and remember I drew that picture that had the beam that was sitting there like this, and it was doing that. If this is going up, if it's trying to shear that up, then the resistance, the internal shear, is trying to push it back down, isn't it? And they say, based on this book at least, that is a positive shear. Because what you're trying to shear off here is going up. Don't shoot the messenger. Am I allowed to say that? Would that be like Donald Trump saying, I don't know about the Second Amendment, people, they might.
Oh, yeah,
If I say don't shoot the messenger, that means don't shoot the messenger, okay? That literally means don't shoot the messenger. Please. If you shoot me, I'm not going to take that one test grade off. You're screwed. Oh, so that's just the way we have to deal with it. I don't know what else to tell you. But it's because this piece right here is pushing up, trying to shear, that becomes a positive shear value. And the moment, then again, is the internal resistance. So, and if you notice on all these problems, the internal resistance is going in the counterclockwise fashion in every problem we do. So,
Come test time, are you gonna give us one that's not gonna go?
I don't think you can, because of the way the beams are set up. I don't know if maybe on a cantilever beam, if you looked at it at close to the end, it might be, that resistance might, but there really shouldn't be any.
What if the beam was horizontal and upward?
Well, then it'd be a column, it wouldn't be a beam.
Let's say there's a load attached to the bottom of it.
It would have to, well, for that thing to be bending, for that column to be bending, it would have to be a side force, wouldn't it? So you basically could reorient it, do the problem, and then, but it would still be the same. The resistance, it would be exactly the same. But it's, at that point, it truly is a column if it's standing up instead of a beam. Okay? Anything else on this? I got to erase that mark there. I can't stand it. Almost looks like a K, doesn't it? Nothing else on this one? So those are the two answers we'd be looking for. We have to get these answers to get there. So don't screw those up. All right, the second part of that problem. Oh, let's see, we weren't done there, were we? That was at 4 meters.
Gotta cut it at 7 meters.
Right. So this was, this is at 4 meters. So now we have to do 7 meters. So that means we're going to have to move this down some more. Okay, so we'll do 7 meters. At 7 meters, and I don't know if I'll do that like that on a test where you have to do a beam at several different places. I don't know. You might. It shouldn't make any difference. Actually, it would make the test easier, wouldn't it? If I only gave you 2 beam problems instead of 4, because then you wouldn't have to figure out the reactions at A and B again. So we'll see. Just depends on what kind of mood I'm in, I guess. So the second half of that then, at 7 meters, because see, we still have that number there, 6.55. Kilonewtons. And on this one though, we do have that 12 kilonewton force out there, don't we? We know that distance there is 5 meters. And then the distance out to here is 7 meters. So we do our V for victory, V for shear. Huh? We add those in. Now we've got 6.55 going up, minus 12 going down, right? So that comes out to a minus 5.45. That number looks familiar, doesn't it? Kilonewtons, or 5.45 kilonewtons. Now this time the shear is negative. We had said it was going, what did we say, it was going down before, right? So this time, in other words, this one is beating it, right? So it's pushing this thing back down. So this is resisting it up. So the shear is actually going up this time. It's a negative value. So since it's a negative value, your internal shear is going up. The moment from the right side, if you will, I'll just say from the right side. Okay, we've got what, 12 kilonewtons? That's going down, so it's negative at 2 meters plus 6.55.
Not at 5 meters?
Nope. At 7 meters. Look, remember, we're taking the moment from right there, right? So 7 minus 5 is 2.
From where the shoe.
Exactly. That's where we're looking. Everything we're looking at, that's why all these numbers are backwards. Because everything we're looking at is for the internal shear at that location. Okay? All the other numbers we were looking for were external forces, weren't they? This is internal. So you have to flip your thinking. The numbers on that then, 21.85 kilonewtons, kilonewton meters, excuse me. Positive, headed that direction. And by the way, I did post the solutions on Blackboard this morning. So they're out there. Chris?
What if the force is pushing up instead of down on that beam? Would then the moment rotation cause it to go the other way, clockwise? I'm still stuck on that.
At the 12 newtons or something?
Yeah, let's just figuratively say the 12 kilonewtons is.
Well, that wouldn't be any different than this one right here. All of the forces on this were pushing it up. But the other part of the beam still has to resist it.
I'm just trying to figure out why it's bugging me. Why is it always going to go counterclockwise? Maybe it's something I just need to look up on my own side.
Well, I can't give you a really good answer other than, I guess if it was going the other way, what would have to be going on there? No, well, yeah, your beam would have to, I think if it were going the other way, right now, the beam is doing, it's trying to bend like that, right? So the beam would have to be going the other way to be resisting it back. No, it's still gonna, see, because if you cut that anywhere right there, this is still trying to, if this is pushing up and you cut it over here, this
The reaction
still has to go that way, even if you're pushing it up. I think the only way you're going to see that moment go the other direction is when you look at it from the other side. You know, if you're, in other words, you cut it here and go to this side, well, what's going on is this one is trying to resist it back this way, isn't it? So it's, I think by default, if we cut it and look at the left side, the moment has to be going counterclockwise. If you cut it and look to the right, then the moment has to be going clockwise. I think that's your, you know, because even if you cut it here, what's this doing? So this is pushing down. So, yeah. Well, it's not, that's not pushing down. I shouldn't have said that. Actually, the force that you'd be dealing with, this force is pushing up, isn't it? So it still has to react that way. Now, if you looked at it from the other side, though, then it would still be going that direction.
What if you look in the book and you, like at problem number 1313, you cut a center section of the beam out where you have those 10 kits,
I gotta find 1313.
off 295.
1313, okay, are we talking
A.
A? Okay, you got 10 kips.
10 kips, so like you cut it on either side of the 10 kips, both those forces would be bending it the other way?
Well, if you cut it on the left side of the first 10 kips over on the right, or excuse me, on the left,
Yeah, you can't
if
take
you're
it-
looking at A, okay,
Yeah.
if you cut it, and you're going to find that out. on this next set of problems
Okay.
that you have to do. But if you, because that's one of the problems. But if you look at it just to the left of that 10 kips, what are you dealing with there? You're only dealing with the AY, and it's pushing it up, right?
Oh, yeah, okay.
And then if you look at it just to the left or to the right of the 10, that first 10 kips, then you're adding that 10 kips back in. So, and on one of the problems that we do for this homework, we had to look at it to the left and to the right of the force, because the force was, you were cutting it right at that force. So you have to look at it to the left of it and to the right of it and see what it's doing, to be fair. Because you just can't do it right at that location. Okay? All right. What else? Anything else? Starting to sink in? I hope. If not, we got a couple more problems yet, so